Okay, now we're going to turn to long run production. So we just finished short run production. And the key thing in the short run was that capital was fixed. Now, moving into the long run, this is going to be the time period for which all inputs are fully adjustable. So both capital and labor can change, right? Both capital and labor can change. One point of clear, excuse me, clarification is about how we define the long run. So I often get the question from students, is there some set time period that defines short run from long run? And there's not, in the sense that we can say, oh, it's 1 year, oh, it's 3 weeks, right? Whatever that might be. It's just how long does it take for the producer to be able to change how much capital they use. So it's often going to depend on the context in which they're operating, right? In the days of Facebook Marketplace and Amazon, where you can purchase things and have them delivered in a couple days, the long run might be 2 days, right? In a world where Amazon doesn't exist, where it's going to take weeks of searching and then weeks of shipping for the new capital goods, new machinery to arrive, that long run is going to be maybe a couple months, right? So it all depends on the context. It all depends on the capital goods we're talking about. All right, so it's going to change case to case. All right, but again, in the long run, this is just when we're able to change both capital and labor from the producer's standpoint. So you can see this reflected in how we write our production function. We've dropped the bar over K, and we're saying now it's allowed to change, right? K is a variable just like L, it's no longer constant. So here in this table now, you're seeing that. So in the previous video, you saw production tables where K was held constant at the same value. Now it's changing with L, all right? So let's look at our K equal to 1 row here and just stay there. So let's say, okay, we're going to keep K constant for now, keep just that single machine in use, not add anything else. How does output vary with labor? That's going to be shown here in this row, right? As labor increases and capital is held the same, output goes up, but at a decreasing amount, okay? We have, if we go from 1 worker to 2 workers, right, we're going to have a jump in output of 0.41 is that delta Q. If we have a jump from 2 workers to 3 workers, right now our jump in output, excuse me, is going to be a little less. So that is 0.32 for delta Q, and that'll be so on, right? So we see again that diminishing marginal product of labor. If instead we hold labor constant and vary capital, now we're going to see the returns to output from additional units of capital, right? Additional machines. So again, if we go from 1 labor and 1 machine, 1 capital good, we have a jump in output of, let's put it over here, that same amount, 0.41, right? That's not always the case, but it is in this. Right? Again, if we jump from 2 capital goods to 3, now we have again a change in output of 0.32. Okay, so again, the same. That's not always going to be the case, but it is in this example. They're symmetric. All right, so you can see again that diminishing marginal product in this case of capital. As capital grows, the amount of output that increases with those capital goods falls. All right. We can show that again mathematically as well. Okay, our marginal product of labor, previously we found to be capital to 1/2 over 2 times labor to the negative 1/2. So that should be positive since it's in the denominator. So as labor grows, marginal product falls. Right. Similarly, capital, right? Let's go ahead and solve for this one. So the marginal product of capital is how output changes when only capital changes. So we're going to treat labor as a constant and only treat capital as a variable. So we'll apply that power rule. So we'll have 1/2 times the constant modifying capital, which is labor to the 1/2 power. So we'll have 1/2 times labor to the 1/2 power times capital. And we're going to subtract 1 from that exponent. So we'll have 0.5 minus 1 in the exponent. That's going to simplify to 1/2 times labor to the 1/2 power times capital to the negative 1/2, which we can rewrite as labor to the 1/2 power over 2 times capital to the 1/2 power. And we see again, right, as capital increases, marginal product of capital is going to decrease overall, right? And that's being seen in the table. The next thing I want to draw your attention to is what happens as capital and labor increase by the same amount together. So if we double capital and labor, we go from capital of 1 unit to 2 and labor of 1 unit to 2. We're going to see then a doubling of output, right? As we go from labor equal to 2 to labor equal to 4 and capital equal to 2 to capital equal to 4, we get again a doubling of output. So this will be something we go into more detail on later in the lecture. This has to do with returns to scale. So how does output change as our inputs change by the same factor together, right? And in this case, if we're doubling inputs and getting double outputs, that means that we have constant returns to scale. Okay. With that, that's going to end our brief sort of dive into what long run production looks like. It's really just that we're able to change both of our inputs now rather than just changing one at a time, or in the short run, just changing labor. And so we're going to use this now to think about what the producer's ultimate goal is, which is profit maximization, right, or cost minimization. For this class, we're going to focus on the cost minimization side, which again is the same as profit maximization, and we'll pick that up in the next video.